these ones. Today, we will continue with classification, and we will try to explain more what's the classification and some example about the real life example from the classification task. And then one of the famous classification algorithm, decision tree, we will mention about the decision tree, how this decision tree algorithm is working. We will try to explain it. Next lesson, we will do some practical examples. Today, a little bit theoretical. Before start, or let's continue. After that, I want to show you one demo during this course. So we can divide it, data mining models into the two categories: predictive model and descriptive model, or supervised learning and unsupervised learning. In the supervised learning, main difference between the supervised and unsupervised learning, in your in your data set, if you have target labels, this means you can use supervised learning algorithm. But in your data set, if you don't have target or output, you can use unsupervised algorithms. State-of-the-art supervised task is a classifier and regression. What is if you want to summarize what is the difference between the classifier and regression, if you are trying to predict the continuous output, like for example, what will be tomorrow temperature, how much degree it will be yesterday, tomorrow temperature, this means you are making classification, you are solving classification problem. But sorry, you are not making classification problem, you are making solving regression task. But if you want to try, tomorrow it will be sunny or cloudy, this means you are making classification problem. In the classification, output is a discrete value. In the regression, output is a continuous value. In the clustering, you have inputs in your data set, but you don't have output. In the association also you have input and you don't have output. One of the famous example for association rules mining is a market basket analyze and a recommender systems. Let's try. Let's give one real life example for the classification. For example, in this problem, there is three types of the Irish flower: Irish setosa, Irish versicolor, and Irish virginissa, and then our algorithm decision data mining algorithm data mining algorithm in this task to solve this task, you can use decision tree algorithm, and then we will try to predict the type of the flower. And then if you are expert, for example, if you have on flower shop or you are botanist, when you look at the image or photograph of that flower, you can tell, for example, this is the Irish setosa, Irish versicolor, or Irish virginissa flower. You can tell if you are expert. But if you are not expert, in that case, you can ask one expert to prepare one data set for you. For example, in this solution of this problem, these Fisher, this researcher collected 150 flower like that, and then he measured the sepal width and length, pedal width and length, and then he write and recorded this data here, and then he already knows the types of this flower, and he write as a target, as a label to the last column in this data set. And then the data set ready now. You can give this data set to the one classification algorithm, and you can make classification. You can solve this classification problem. And we will do this real life classification problem later. Now I want to show you one demo about it. For example, by using classification algorithms, one of them we told famous of them, decision tree. You can develop like that one application. For example, this is a web application. Let's make it as this is a demo. That's why I will not explain how to develop this application, but in the next coming lesson, we will see how to make like that one application. For example, you can develop like that one application, and you can tell, for example, 5, sepal width 3, pedal length 2, and pedal width 4, for example. And then you want to know if you have one flower with these properties, and then you want to know what is its type. And then decision tree algorithms or classification algorithm is telling you if you have one flower with these properties, you have Irish Virginissa flower. You can develop like that one web application, machine learning or data mining web application. Or you can develop it Windows version. For example, think you have one flower and you measure, you bought one flower, Irish flower, and then you want to know its type. Yes. How can you know? You have two options to know it. You can ask one expert about it who knows properties of that flowers. You can ask him, or you can ask this application. This application is a expert system. On the background of it, there is one machine learning algorithm working, and then it is making prediction according to the specification you have provided. For example, if sepal length is a 6, sepal width 3, pedal length 5, for example, your flower, these properties, and then you want to know what is it. And if your flower has these properties, most probably your flower should be Irish Virginissa type. This is one example machine learning Windows-based application. You can do like that. This was one real-life example for the classification problem. In the previous lesson, we give this example also. This is a churn prediction example. We have explained it before. I don't want to explain it again. And today, we will use this dataset. This is one of the benchmarking dataset, especially for the decision tree algorithm, to test the decision tree algorithm performance and status. For example, in this dataset, what are there? For example, we have 1, 2, 3, 4 input, and then we want to know if they will play tennis or not. For example, if outside sunny, they did like that, they watch out and they get some experimental data. They collected experimental data for 14 days. In the first day, for example, they observed that if outlook sunny, temperature is hot, humidity high, wind is weak, they didn't play tennis. Another day, for example, it was, for example, sunny, hot, high humidity, and then strong wind, and they didn't play again tennis. And another day, it was overcast, hot, high, and weak, and they played tennis. Is a simple data set. You can collect like that data set by making experiment, and by making observation, you can collect like that data set. This is one example benchmarking data set. And then we want to know now, we want to develop one classification, classification, machine learning or data mining model. In our model, how many input we have? We have 4 columns since 1, 2, 3, 4. Our input is outlook, temperature, humidity, and wind. And we see output is a discrete values. categorical values, not continuous numbers. Yes or no? That's why it is a classification problem. Yes, that's why you need to use classification model. This machine learning model should be classification, not regression, not clustering, not association. This should be classification because your output is a discrete, not continuous value. And you should choose one algorithm. You can choose one classification algorithm. One of the famous ones is the decision tree algorithm. In this lesson, we will mention about the decision tree algorithm, and we will try to learn how decision tree algorithm is working. We will use decision tree algorithm to solve this problem. And our output label or class label or target either play tennis, yes, or they will not play the tennis, no. It will be yes or no. If it is yes, they will play tennis. If no, if they will not play the tennis. So when you develop one decision tree model, it looks like that. It looks like tree. That's why they are calling it decision tree. For example, if you give this data set, to the one decision tree algorithm, this decision tree algorithm automatically will produce like that one tree, similar to that tree. This tree is our decision tree classification model. And now your model, when your model ready like that, you can guess any input. For example, if outlook rainy, you will come to here. If it is rainy, you will follow this way, rainy. And you will check wind. Wind is a weak. And then if wind is weak, they will play the tennis. And answer of this question is they will play tennis. There is also a temperature and humidity. In this condition, these one is not important because most important one is the outlook. That's why first you should look at in your given data outlook. After that, because of rainy, you split into this direction. You'll go into that direction. And then next time you'll check the wind attribute with input. And then you'll check if it is strong or weak. And here, since it is a weak, output will be yes. This means if you have like that weather condition, if outlook rainy, temperature is hot, humidity is normal, wind is weak, they will play tennis. And you can make prediction according to this decision tree model easily. If you want to know they will play tennis or not, you can make like that prediction. You can tell most probably they will play tennis. How you are telling this one? Because of you are making this prediction because of the past experience, historical data. This is very important. This is a past historical data experience. And you watch them for 14 days, for example, and you get some record. And you look at the outlook, it's sunny, it was sunny. Temperature, it was hot. Humidity, it was high. Wind, there is a weak, and they didn't play tennis. You collected this data by making observation or you experiment. After that, you gave this data to the decision tree algorithm. You feed it this data to this decision tree algorithm, and decision tree algorithm is trained. When it's model ready, decision tree algorithm generate this tree. Now, this is your final ultimate model. You can use this model to make any prediction, which is not available in this data set. If data, for example, if somebody asks you, if outlook is overcast, temperature is hot, humidity is high, wind weak, you can directly tell yes. But if somebody asks you one input which is not available in this data set, in that case, you can ask this model, decision tree model, and to give this decision. Now, we will try to understand how to develop. First, in this lesson, we will generate this decision tree manually by making some calculation. Next time, we will not do this calculation. We will ask the decision tree algorithm to build or to generate for us decision tree model for us. For this lesson, we will, by using this benchmark data set, we will produce manually. And before produce this one, let's understand the decision tree well. For example, there is a root node. If there is no income and 0 or more outgoing edge, this is a root node. This is a, in this decision tree is a terminologic word. This is a root node. This one node, this one node, this one node. But this is a root node because there is no incoming here. There is no incoming here, but there is some outgoing direction. That's why this is a root node. Internal node, each of exactly one incoming and 2 or more outgoing. Look at, for example, this one is an inner node because it has one incoming, one or more outgoing. Here in this example, there is a 2 outgoing. This one is an inner node. And leaf or terminal nodes, each of which has exactly one incoming edge and no outgoing edge. So, for example, this is a leaf or terminal node. It has exactly one incoming and no outgoing. That's why this is a terminal or leaf node. This is a root node, inner node. This is a terminal or leaf node. Internal node, and root node. This is an example. This one also internal node. This one also terminal nodes or leaf nodes. So each leaf node assigns a class. For example, it is a yes class, no class, yes class, no class. Also, non-terminal nodes or internal nodes contain attribute test condition. For example, this like that node, it has one test condition. In this place, you will ask if humidity high or normal. You will test here. If you are here, you will test if wind is strong or weak. Is the test condition. This 2 is a test condition for this node. Test condition. Terminal node is a decision. Yes, terminal node has a decision. If you reach here, this means you find one decision, yes or no. So what is the aim of the classification algorithm? Aim of the classification algorithm, search to best splitting node. For example, this decision tree algorithm search among these 3 of them: outlook, temperature, inputs, humidity, and wind, and decided to outlook is the best splitting place. And that's why outlook appeared at the top. Yes, all decision tree aim this one. So how decision tree decide this best splitting node? By using some measurement. For example, there are several decision tree algorithms. One of them is a CART, for example. One of them ID3, one of them C4.5. They are the famous decision tree algorithm names. If you search them, you can see many information about this decision tree algorithms. For example, this CART decision tree algorithm using split or Gini-index to find the best splitting point. For example, to find this node, it is using which technique? These techniques. For these algorithms using information gain and entropy. Today, we will mention about information gain and entropy. If you are using this type of algorithms, they will find the best splitting part node by using information gain and entropy. So there is other metrics. For example, you can use information gain, you can use Gini-index, Gini-impurity, split info, gain ratio. You can use one of them to find the best splitting node. They are our criteria. For example, if you want to use information gain, formula is here. Information gain formula, this one. All of them has a formula. You can calculate them one by one. For example, if you want to find the entropy, if you want to use entropy, you can use this formula. If you want to use Gini, you can make calculation by using this formula. Now I will explain some of them. So, for example, if you want to generate your decision tree using entropy, yes, we want to information gain. We want to, for example, if you want to generate your decision tree by using information gain. Yes, information gain. This formula. We want to, for example, find the best splitting node by using this formula. In this formula, there is an entropy also. You should understand what is entropy and how to calculate this gain. Let's try to understand what is entropy. We are going to use entropy in the science, especially in the chemistry. Yes, entropy means measure the level of the impurity. Pure. If something is a pure, nothing inside it. Only, for example, if it is pure white, it is a only white color. If it is not impure, there is something other colors inside there. Dirty white. For example, dirty white color is a one example for impurity. Yes, pure white, only white color is an example for pure white color. Impurity, level of the impurity. For example, this one is a pure. You can see this set is a pure. Only in the set there is only squares. But this set is not impure. In this set, we have some square and triangle. We have two categories information. Yes. And then when you calculate their entropy, for example, when you calculate the entropy of this set, you will see one. High entropy means impure, maximum impurity. Low entropy, for example, low entropy 0 means minimum impurity. Minimum impurity. Minimum impurity means it is a pure. Yes. Maximum impurity means it is not pure. There is not something else inside it. But here it is a pure set only. In the set only squares. How can you calculate now? By using this formula. For example, sum of the probability of the first class times logarithm. This one is a base 2 logarithm. Probability of the all. So not probability of the all, probability of the each class times log probability of the each class. Yes. Here, for example, here, how many class we have? 2 class. One of them triangle, other ones are squares. Yes. For example, what is the probability of the squares? Probability of the squares. Probability of the squares. 1, 2, 3, 4, 5. 5 square we have. Altogether, all of them is a 10. That's why this one. Yes, this is not division. This one. Bar. Probability, you will calculate this one. This is equal to 5 division by 10. Yes. And then next one is a multiplication. Multiplication. Multiply log, we told this is a base 2. log 2. Again, probability of the same thing. 5, we have 5 square divided by altogether 10. This is since there is a minus in front of it, there is minus, yes. Again, minus. Now, what is the probability of the second class? This is a first class. Now, sum. Probability of the first class times logarithm of the probability of the first class plus this one, sum. Second class probability. Triangle probability is the same because there is a 5 triangle 5 divided by 10 times formula times log base 2 again probability of the triangle 5 divided by 10. When you make this calculation, you can make this calculation in any application. It is not deleting, no problem. You can make this calculation in any program. For example, in a Python, you can do this calculation. Control enter. This result is a 1. Yes, if you do this calculation in the Python, you know how to use Python, you can make this calculation. And the result is 1. By the same way, for example, here, probability of the squares is a 8 divided by 10, because all together 10. This square is 8 pieces here. Yes, 8 divided times log 2, 8, 10. Again, probability of the squares minus probability of the triangle times log 2 probability of the triangle. And when you do this calculation, you will see this one. And then if all of them from the same class, probability of them is a 10 divided by 10. Log 2, 10 by 10, result is a 0. So this means entropy of this set is a higher than this one. This means we told impurity also we can tell this order. There is no this order here in this set, but in this set is that there is order. Everything is from the same class. This has high disorder. This one is a less disorder. This is an ordered set. This is a disordered set. You can tell. You can measure the entropy like by using this formula. So what is the relationship between the entropy and the probability of the positive class? If, for example, here in your set, everything is a minus set, minus group. For example, let's tell everything triangle here. Let's tell here everything is a square. Here, some of them, half of them triangle, half of them square. And then entropy of this set is higher than this one and this one. And then if entropy is higher, here for this set, entropy is higher, there is a disorder. In this set, there is a disordered set. This one is an ordered set, and this ordered set. So probability of the minus group is a reverse. For example, here, probability of the plus set is a 1. If 1, probability of the minus set is a 0. Yes. Here, probability of the, for example, triangle, if you tell them triangle set 0, this means probability of the plus set is a 1, reverse. You can get some, if you have two classes, for example, in this example we have minus classes and plus classes. In the previous example we have triangle class and then square class. In the example, play tennis or not play tennis, all they have two class problem, and maximum entropy can be 1. If you are solving 4-class problem, maximum entropy can be 2. 8-class problem, in the 8-class problem, maximum entropy can be 3. If you have 16-class problem, maximum entropy can be 4. So actually this entropy coming, we are going to use entropy in the information theory. Let's mention about the information theory shortly. It is actually, we are not in, our lesson is not information theory, but let's try to understand what is information theory. For example, if you have one data, A, D, C, B, B, D, C, A, and then you want to transfer it from this place to this place, from the PC1 to PC2. You want to transfer it from this information from this place to this place. So how much bit you need? If you want to transfer this knowledge from this place to this place, you need to code them. Yes. How many different letters we have? A, B, C, D, 4 different letters. That's why you can use this coding system: 0, 0, 0, 1, 1, 0, 1, 1. For example, you can tell A, 0, 0, B, 0, 1, C, 1, 0, D, 1, 1. We can tell like that. For example, how many bits you need? There is an 8 symbol here, 8 symbol. 8, all of them is a 2 bits. This one, 2 bits. 2 bits. 2 bits. This one, 2 bit, 2 bit, 2 bit. And then we have 8, 16 bits. You need to transfer. If you want to send this knowledge, this text from this PC to this place, you need to use minimum 16 bits. Yes, you should transfer minimum 16 bits. For example, first of all, you need to transfer 0, 0. When this PC gets 0, 0, it will send you get A. Yes. Next time you will send C. C is a 1, 0. You will transfer 1, 0 signals. And then 1, 0 signal is a C. You will transfer them. Already you know these things. Computer can work with binary system because in the computer we are going to use digital signals. For example, this one. If you send this signal to the other side, this means D. Yes, because 1, 1. 1, 1. But if you send this signal to other side, this one 0, this one 1, 0, 1, 0, 1, B. This means you send B to other side. Yes, digital signals has a, either there is a signal or there's no signal. That's why you need to send minimum, you need to use 16 pulse or 16 bit you need to use. Yes. Also, what is the probability of the A? How many times there is A? 2. 2 times A. We will use this probability because 2 times. And altogether, how many? All these symbols, 8. And if you simplify, 1 over 4. Probability of the A, and actually probability of the B same because we have 2B. C also same. Probability of the D same. We will use this probability. And we have already solved this one. You need to, if you use this coding system, if you will code the A, symbol A with 0, 0, and if you code the B with 0, 1, if you code the C with 1, 0, if you code the D with 1, 1, 1, if you will use this coding system, you need minimum 16 bits to transfer all this one, and you need per symbol minimum 2 bits. You need 2 bits. You need to use 2 bits per symbols. How also you can find these 2 bits? How can you find? By using, look at this, looks like entropy formulation. Yes. What was the entropy formulation? This one. So entropy is going to give us to how much bit you need per symbol. If you put this probability, what is the probability of the A? We told in 1 divided by 4. Yes, probability of A 1 divided by 4 times log 2 probability of the A. Yes, minus because of sum, minus sum, minus what is the probability of the B 1 over 4 times log 1 over 4 minus again what is the probability of the C, same. Yes, and then this one is exactly entropy formulation. And if you use entropy, also entropy is going to give us, we told it is very important. And by using entropy, you can find how much bits per each symbol you need to use minimum 2 bits. Yes, we can solve this one by hands, but if you have different letters, symbols, or different number, it is better to use this formula to find how much bits. But in this question, for example, in this question, again, if you use this system 0, 0, 1, 0, 0, 1, 1, 1, you need 2 bits. Yes, we calculated before. But to optimize, to send this data from this place to another place, another PC, if you use this coding system, you need 2 bits minimum for each symbol. But if you change your coding system, you need 1.75 bits. 1.75 bits. It is a more optimized because you are using less bits to send, less pulse, electrical signals you are using. Yes, if you use this coding system. But for example, you are coding A. For example, A will be translated 0, B 1, 0, C 1, 1, 0, A again 0. You are converting these symbols into these binary bits, and then you are transferring. You can transfer it to the other side. And this time, how many you have? 14. How many letters you have? 8. 14. You have 14 bits if you count them. 14 bits here. 8 symbol or 8 letters here. You need 1.75 bits. And then how can you find this one without thinking it like this? You can solve this one from your mind. Which coding system I should find, but this is simple. But if I will ask harder question, you cannot solve it with from your mind, and you need to use entropy formula. Entropy formula, what is the probability of the A? How many A? There is a 1, 2, 4, 1, 2, 3, 4. How many altogether? 8. If you simplify it, 1 over 2. Probability of the A, 0.5 or 1 over 2. Probability of the B, again, how many B? There is a 1, 2, altogether 8, 1 over 4. And like that, you can find the all probability, and you can plug all these probabilities inside the entropy formula. Our entropy formula, it was here, look at. probability of the first class times log 2 probability of the first class minus probability of the second class times log probability of the second class. This is the probability of the first class times log probability of the first class minus probability of the second class, B, this means here B, times log 2 probability of the second class minus probability of the third class, this one, times this one. And then if you do this calculation, and you will see it is a 1.75. You can do this calculation either in Python or this is done in the MATLAB. $1.75. Yes, 1.75. So you can do this calculation either in MATLAB or in any method you can use Python, or you can use Python and you can do all these calculations. So if you want to send these symbols from this place to another place, minimum you need 1.75 bits information. How did you find this one? By using entropy. In the information theory, we thought in the information theory, we are going to use entropy to find minimum number of the bits to send to our information from one place to another place. Here there's a one thing, for example, think in your population, there is some people, four of their age in between 0 and 10. 5 of them in between 10 and 20. Like that. When you calculate their entropy, you'll see 2.5. In another population, for example, in another group, there is their ages distributed in this like that. And then look at this one. Which one is the better, you think? This one or this one? I think this one should be better, more information. Not more information, better ordered. You can discover from this data more pattern because it is a ordered entropy. When you calculate the entropy of this group, it is entropy of this one smaller than this one. This means you can discover more things from this data set. This means this data set looks better to use in classification problem or in machine learning problem. You can more, it is more things inside it, more pattern. It may contain more pattern. It looks like that according to the entropy measurement. The one example. We mentioned about this one. So now we will calculate information gain. Why we will calculate information gain? We have explained up to this point all to understand what is entropy. Because inside the information gain formula, we are going to use entropy formula. Entropy formula. Yes. And then we will calculate the information gain for every node. For example, you calculate the information gain of the outlook, information gain of the temperature, information gain of the humidity, information gain of the wind, and then which one has a much information gain, which one has a much information gain, we will put it at the top of the decision tree. Information gain formula, this one. So we can define the information gain, expected reduction of the entropy, because we are subtracting whole set. S is a whole set to the classes, subclass. This one is the subclass size. I will explain them more when we are doing calculation. And it is going to expect reduction because there's a minus between them. Again, let's remind our question. Our question is by using this data set, we want to generate one decision tree model. And our input is an outlook, temperature, humidity, and wind. And output is a label, class. Yes, that's why this is a classification problem. Now, let's calculate the whole set. S is a whole set. Entropy S. How can you calculate? In a whole set, how many data we have? 14 data. Yes, 14 data. 9 of them plus. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them plus. 5 of them minus category. No, 1, 2, 3, 4, 5 of them minus category. This means inside it there is a 2 category. Yes. First, probability of the yes, 9 over 14. Logarithm 2, this one of course. Logarithm 2, 9, again this one. And then what is the probability of the no class? Since there is a 5 no, 5 divided by 14. And logarithm 2, 5 divided 14. And in the MATLAB, if you calculate this one, and you will find this value. So calculate this one, you should scientific calculator. But when you are using scientific calculator, don't use normal logarithm, log 2. Be careful. Use log 2, logarithm 2. Because we are working with binary class. Yes, binary class. In MATLAB you can do, or in the Python you can use MATLAB, or you can use Python, or you can use scientific calculator to calculate the entropy of all this set. Now for wind, we want to calculate entropy. Inside the wind, we have 2 options: weak or strong. Weak, entropy of the weak, entropy of the strong. In some sources you can see S, in some of them you can see D. It is showing set. And how many, from the weaks, how many of them yes? 1, 2, 3, 4, 5, 6 of them yes. 6 of them yes. Among the weaks, we are not looking at the strong. Among the weaks, how many of them minus 2? 1 and only 2. Yes, we'll calculate them. Among the strongs, 6 of them has a positive result. They will play tennis. 3 of them has a negative result. Yes. Now let's calculate for this one is for wind. Yes, wind class. Wind. For all of them, for all wind, for all of them, 9 of them. If we consider all weeks, 9, there is a 9 yes here, and 5 no. Yes. Entropy of the wind, you can calculate by entropy formula like that. That's same. For all wind. So inside the wind, for the weeks, if you want to calculate entropy, you will find this one. For wind, entropy this one. For the wind weak, entropy this one. For the wind strong, entropy this one. You can calculate by using formula. By using this entropy formula, same formula. When you find the entropy, now we will find the gain. Yes, gain. In the gain this one. Entropy D means for all set. For all set, this one. We calculate it here. Look at for all set. For all set, because in the all set and wind, look at how many of them yes? 1, 2, 3, 4, 5, 6, 7, 8, 9 yes. Yes. How many of them no? 1, 2, 3, 4, 5. Yes. Don't mix it. For all entropy, we calculated it before 0.9. This one. This one. So this is a subset. We told subset. What is the size subset? Subset is that we have two subsets. One of them weak, other one is a strong subset. Yes. We calculated already these ones. Yes. Entropy of this subset d weak. Entropy of the d weak already calculated here. Entropy of the d weak, this one. We are just plugging this one into the formula, into this place. So what is the entropy of the d strong? We already calculated here. Is strong. Here, this one. 1. Yes. We'll plug this value to this place and then to this place. So what is the probability size of the weak? Size of the weak? 3 plus 3, 6. Yes. What is the size of the whole set? Is the bar means size. Yes. 14. Again, for this strong, for d weak, again, what is the size of the weak? What is the size of the weak? 6 plus 2, 8. 8. What is the size of the all? 14. All 14. 9 plus 5, 14. And gain for wind attribute is a 0.048. And you can calculate the same methodology. By using same methodology, you can find the gain of the humidity. And you can find the gain of the outlook by using same methodology. And at the end, you can tell, for example, gain of the outlook is higher than all others. That's why outlook will be our first node. Best because gain according to the outlook nodes is higher than other ones. That's why is according to the gain splitting criteria. We are choosing outlook at the top. Yes, outlook. And you'll continue like that. For example, when you'll take only outlook. Sunny. If outlook is sunny, from this data set you can bring. You can filter and you can tell if outlook is sunny, 2, 3, 4, 5. There is a 5. You will bring only this data from here. How many? 1, 2, 3. 1, 2, 3, 4, 5. If you bring all this data to here, 1, 2, 3, 4, 5 data. That's outlook. Now, our data set is not all data set. Now this one. Again, you can find the entropy of the sunny. Entropy of the sunny. How many of them belong to the yes class? 2 of them. 2 of them belong to the yes class. How many of them belong to the no class? 3 of them. Yes, 3 of them belong to the yes class. And you can plug these values into the entropy. Probability of the plus 2 over 5. Logarithm 2 over 5. Again, this is log 2. Don't confuse log 2, this one also. And probability of the minus class is a 3 over all of them 5. There is a here all of them 5. Log 3, 5. And entropy of the sun is a 0.9. Again now for sunny you can calculate for wind. Yes, for wind. for wind. How many of them weak? 1, 2, 3 of them weak, 2 of them strong. Yes? 2 of them strong, 3 of them weak. Yes? Again, you can calculate this value, entropy of the weak, wind weak, entropy of the strong, but not all dataset for this dataset. Only for this dataset. Humidity. Again, gain in respect to the humidity, but only for this dataset. This dataset. Yes, for this dataset. Again, this one. And which one is the biggest? Humidity. And next time we are going to do sunny and humidity. Next branch is because humidity is next one will be humidity in the direction of the sunny. In the direction of the sunny. We find that this branch from outlook if sunny. Yes, this one. If outlook sunny. By the same way, you'll find if outlook is overcast, when you can see, you don't need to make any calculation for this one. This is special. Let's come here again. If outlook is overcast, look at this one. Let's delete some of them to see better. Overcast. Here we have one. We have one here, 2 more here. Okay, always is a yes. This one is a yes. This one, yes. This one, yes. That's why you don't need to make any calculation for this. If it is outlook is overcast, you can tell directly, you can conclude directly. Yes. If outlook, when you look at outside, if outlook is overcast, always they will play tennis. That's why you can give this decision directly. But for sunny, you should calculate again. For this dataset, you should calculate again. By the same way, for rain, you should calculate. You should bring here on the rainy dataset, and you should make calculation, and you should calculate this branch result. What will come here? Yes, which node will come here? You need to make calculation. And to make for that calculation, you are filtering out if outlook is a rain, only rain. Your data set needs this one, yes? All of them is a 1, 2, 3, 4, 5. That's why set is a 5. And 3 of them positive, yes. 1, 2, 3 of them positive, 2 of them negative. No. Yes. And you plug this information into the entropy and you calculate entropy for rain, if outlook rain. And you'll calculate all of this one. And then you'll find, for example, you'll calculate in respect of the humidity if rain, if in respect of the wind, if rain, outlook, in respect of temperature, if all rain. Yes, this one is the highest gain. That's why if outlook is rain, this means next node will be wind. This one wind. This one is all. You don't need to make calculation with all, because if outlook is overcast, always yes. If outlook is sunny, it was humidity. So you can check. Look at now. Let's check this one and this one correct. If outlook is rain, wind, if outlook rain, wind, weak, Yes. Rain, wind, weak. Yes. Rain, wind, weak. Yes. Yes. Rain, wind, strong, strong. Yes, that's why this one is a weak. If it is weak, you forget this one. If weak, they will play. If strong, wind strong, strong, they will not play. You can test this one, humidity. If outlook is sunny, humidity high, they will not play. If sunny, humidity high, they will not play. If sunny, humidity high, they will not play. If there's no other option like that, it's correct. If humidity, outlook sunny, humidity high, they will not play. If outlook sunny, humidity normal, they will play. If outlook overcast, they will play always tennis. Yes. We can find all, and then we construct this decision tree this time manually by using calculation. Yes. But next time, we will give our data to the decision tree algorithm. Decision tree algorithm will generate this model for us. When you have this model, you can ask any question. For example, if outlook rainy, wind strong, they will not play tennis. Yes. So when you have tree, you can virtually you can inspect your tree like that. For example, if outlook is sunny, humidity high, they will not play tennis. Also, you can convert this decision tree graph into the rules. For example, you can write that rule 1. How many rules you can produce from this tree? You should look at how many branches you have. How many branches we have? We have one branch here, one, another branch here, 2, 3, 4, and 5 branch we have. 5 rules. This means we can produce 5 rules. Each branch of this tree is a one rule. First, look at the first rule. What is it? If outlook sunny, and this one is the end, this one end, humidity high, then play tennis, no. Yes. Second rule, if outlook is sunny, and humidity normal, then play tennis, yes. And if outlook overcast, you don't need to look at another features, then they will play tennis always. This is an interesting rule. And you can find the other rules. You can convert this decision tree model into the rules like that. Every branch is a one rules. So today we produce our decision tree manually, making some calculation. But in the next lesson, we will produce this decision tree automatically.